So we said that a regression is basically taking information or data and finding an equation. So the most basic level of doing that is if I'm given a graph and they ask me to find the equation of that graph. So hopefully we remember how many transformations did we talk about in our previous sections? We had what? 4. Do you remember what they are? Yes, no, maybe. Which one tells us how high and low we go? Amplitude. So that's our A value, right? Which one tells us how stretched or squashed we are? The period, which is our B value. Which one tells us that if we've moved left or right? Your C value, which was your horizontal or phase shift. And then which one tells us if we've moved up or down? Your D value, which was your vertical shift. So basically, we're trying to find those 4 things about this graph. And once we find those, we can plug in the values into our equation. Yes? No, maybe? Now, the hard part about these graphs is because they repeat themselves. You don't have like a starting and ending spot. And then also because we're dealing with radians and like pies and things like that, some of our numbers aren't going to be super nice. So we have to come up with kind of some formulas on how to find those things. Are we all with me? Yes? Because once we find or figure out what the formulas are, then we can just use those formulas. Right? We don't have to think about them every time. So what did we say that our A value is? Amplitude. Now, do we remember what our definition of amplitude is? We might have to flip back in our notes. Has to do with our maxes and mins, yes? Almost half the distance between our maxes and mins. Okay? So how do I write that like as an equation? How do I write half of? 1/2. Just 1 over 2. Okay? Half of the distance between my max and min. So what am I talking about when I'm talking about the distance between? Usually we're talking about deltas when we're talking about x values. Here we want to talk about y values.
So you just want to subtract.
Correct. So we want to subtract our 2 values. So we're subtracting our maximum value from our minimum value. And because we're talking about maxes and mins, we're talking about vertical, yes? So we're talking about y values. Are y'all with me? Yes? Subtraction gives us the distance between, and then I just multiply it by 1/2. So for this graph, what is our y value for our maximums?
2.
What is our y value for our minimums?
-4.
So 2 minus a -4 gives us times 1/2 gives us 3. So that's going to be our A value. Yay. What about our D value? What does our D value give us? The vertical shift. But again, if I don't know like where I started, yes, then we can't figure out where that is on my graph. But it is going to be the midline of our graph. Because remember that our vertical shift has to be exactly halfway in between our max and our min. So how do I find a value that's exactly halfway in between? How do I find an average?
Add them and divide.
Correct. So basically it's going to be really similar to our previous one, but this time I'm going to add instead of subtract. Yes? So this time I would have 2 plus -4. So what do we get? -1. Yes, so that means that we've been shifted down. Which makes sense because if I look at my minimums, -4 is going to be 3 units away from -1. 2 is going to be 3 units away from -1. And that's what our amplitude was. Yes? So then what's next? We gotta move to the inside stuff, yeah? Which one do we want to look at first? B, sure. What does B give us? The period of a graph. Okay? Now, when we're given a graph, normally we take 2 pi and we divide by B, and that gives us the period of the graph. Agreed? What is period?
The distance in between to each max. Like there's 2 maxes distance between them.
Correct. So it's how often it takes to repeat itself, right? So you could either look at your zeros, we could look at our maxes, we could look at our mins. So it's just going to be how often it repeats itself. So we can figure out what our period is from our graph. Okay? So then we're going to use that period to solve for our b value. So basically we're working our way backwards. Normally we have the b value and we use that to find our period. Does that make sense? So how would I change this equation to solve for b? Can't do that. B's in the bottom. P, what?
2 pi.
So how would I get my b out of the bottom? Multiply both sides by b, right? And then how do I solve for b? Divide by
So it'll be 2 pi
p. Correct. So we have 2 pi over p equals b. How do I allocate with that? Yes? So what does that mean we need to find from our graph? The period of the graph. And we said that the period is going to be the distance between, we said that we could use x values, right? But x values are usually 1. Are these x values really my x values? Because we said we're going to think of our vertical shift as our new x values, right? So we would need to know where it hits -1. Well, those numbers aren't going to be super nice. Agreed? So what might it be helpful to use instead? We said it's also the distance between what? Yes? We're all very quiet. Are we all with me? The periods is how often it takes my graph to repeat itself, right? I'm talking about x values. Yes? Are you with me? So if I'm looking at this graph, I don't want to use my x values because they're not super helpful. However, it is easy to see where my maxes and my mins are. Yes? So if I look at the distance between 2 of my minimums or 2 of my maximums, that's how long it takes to repeat itself. So that distance would have to be the period of the graph. Yes? Are we okay with that? So again, we're talking about x distance this time. Yes, because we've moved inside of our parentheses. So again, how do we find distance between 2 things? We're going to subtract, yeah. So this time, there's a couple different ways you can do this. We have mins and maxes, so we can use either one. So we can either do one of our maxes, minus our other max, so max 2 minus max 1. We can also do our second min minus our first min. Or what would be the distance between a maximum to a minimum? Is it going to be a full period? It's going to be half the period. So we could also do 2 times a maximum minus a minimum. Now, all of these are going to be what type of values? X values. Because again, once we move to the inside of our parentheses, we're not talking about X values instead. We're okay with that? Yes? Okay. So for us, we're going to find the period first. What do we want to use? Maxes? Mins? Both? Does it matter? Well, since we're given both, we might as well use one of them. So do we want to use mins or maxes? Min, sure. So I'm going to start with the second one. That's what min 2 means. So again, we're talking about x values. So I'm using my 5 pi over 4. I'm subtracting my first x value. So that would be pi over 4. So what do we get? 4 pi over 4, which is also pi. So is my b value pi? No, why not? What does b equal? 2 pi over p. So 2 pi over pi gives us 2. So none of these parts are necessarily hard to find in and of themselves. It's just a lot of adding, subtracting, multiplying, dividing. There is just a lot of pieces to it, if that makes sense. So I will give you these equations, like amplitude, A equals your max minus your min, D equals 1/2 your max plus your min. I will give you all of those on your test. However, you have to know how to find that information from your graph and what to do with it. Does that make sense? Okay. So then what's our last variable to find? Our phase shift, which is given to us by the C value. And it is, not that it's like complicated, but it is a little bit trickier than some of our other ones. Okay. So normally when we find our phase shift, we take our bx minus c, and what do we set it equal to? 0, because normally we start at a 0, at 0 for our sine graph. Agreed? But what did we say is going to be kind of hard to find? Zeros, right? And kind of the starting point as far as zeros go, yes? So what did we say is easy to find from our graph? Like what points are easy to find from our graph? Maxes or mins, agreed? So if I wanted to use my maximum, again, normally we set it equal to 0 because we use a 0. If I'm going to use a maximum, where does our maximum normally happen for sine? It happens at 1. What kind of value is that, though? That's the what value? That's the... We have 2 types of value, x values and y values. One is the what value for sine?
That's the y.
That's the y value. We all agree with that. That one is the y value for sine. Yes, but what did we say? Whenever I start using bx minus c, what type of values do we have to use? X values. So at what x value does sine equal 1? No. Remember, sine equals 0 at 0. That's why we're not using the 0 this time. No. That's the y value, right? So I have x comma y. It's going to be something comma 1. I need to know what the something is.
Pi over 4.
Not pi over 4. Sine is square root of 2 over 2 at pi over 4. 2 pi would be all the way around, so it would be back to 0. Pi, it's at 0 again.
Pi over.
I heard someone say it.
Pi over 2.
It's pi over 2. maximum at pi over 2. What would I want to set it equal to if I wanted to use the minimum? Where does sine have a minimum?
You just add pi.
Which gives us
3 pi over
3 pi over 2. So this is because I'm using a maximum. I'm putting it equal to pi over 2. If you used a minimum, you would put it equal to 3 pi over 2. Okay? Now, did we already find our b value? Yes? Right? We found b? Yes? So I can plug the b that I found into here. Yes? So then the last thing that we want to do is I'm setting it equal basically to the old value. I'm going to plug in the new max x value. So let's look at what I mean by that. We have bx minus c, and we said we want to set it equal to pi over 2. What did we say our b value is for this graph? 2. And then for my x value, I want to plug in the new maximum x value. So where does our graph have a new maximum at? 3 pi over 4. So that's what I'm plugging in for x. So now, how many variables do I have left? How many variables are left? Just one. So can we solve that equation now? Yeah. What is 2 times 3 pi over 4?
6 pi over 4.
Which is the same thing as?
Pi. 3 pi over 2.
Mm-hmm. Right, so then we could add c to the other side. Yes? And then we would subtract pi over 2. So what is 3 pi over 2 minus pi over 2?
4 1. Yeah.
2 pi over 2, which is also just pi. We're all okay with that. And so that's kind of why we wait to find the c till the very end. Because we kind of need the other information in order to be able to find it. So now do we have all 4 of our transformations? A, B, C, and D. So now we're just going to make the equation by plugging all that stuff in. So y equals 3 sine of 2x minus pi minus 1. Why did I put a minus pi instead of a plus pi? This is the opposite direction that it's moved. Or my original equation, right, had a negative sign there. So we kind of need to understand this process. It's going to look a little different if we're given different graphs. So that's why it's not necessarily the number parts. We need to understand, like, the equation parts that we have there at the bottom. You with me? Questions about how I found any of that information? Yes, no, maybe?